Hello, everyone. My name is Michael St. Clair, and today I am going to be talking about an application that I've built with LiveView and kind of some of the challenges I've run into and how I solved them. So before I get started, I have been, just a little bit about me. I have been working with Elixir since 2016 when a startup I joined started rewriting a PHP application into Elixir. And from there, I have just continued to really expand my Elixir skills and also work with DevOps and kind of an interesting intersection of how those two come together. And I help our team at PDQ, both DevOps and app architecture, and solving really interesting challenges. So if you saw my talk last year, I talked about how we were load testing our WebSocket connections, and we were at 2 million WebSockets that we could sustain. And this year, we got up to 4 million. So that was a really fun, kind of one of the things I was able to do with both of those skills together. Then on top of that, I have been building a side project in LiveView for the last few years. And that is what I'm going to be talking on today. So it's built entirely in LiveView. One of the products is QueryDesk. It's part of a whole suite of tools that I call DevHub. So you can get more information there, but also a QR code. Or you can go to that link and find the gist named ElixirConf 2025. I have some relevant links if you're interested to follow along with some of the code. There's also the open source version of QueryDesk available, so you can actually see how I built most of this if you are interested. So before we begin, what is QueryDesk? And that is, it's a database access management tool. It allows you to configure granular access all the way down to a column level for your databases, and allows you to hide PII, for example. And the really common use case that I've seen for this, and especially with my teams at PDQ, is developers need access to your production databases to really effectively do their job. And sorry. But then, when giving access to the production databases, you'll a lot of time run into compliance or security issues. A lot of times, you start up with startup, you have a couple developers, just give everybody the production password, and then they can go in and fix data when they need to. QueryDesk now makes this easier. So you can give all your developers access to your databases, and even staging or your developer environment databases, to be able to have a convenient, easy access in the browser. And then, so you can give them read-only access. You don't have to give them the database password. They are able to just use their own user login, and all the queries they run get tied to them. But if you need to elevate access and say, I need to change some data because some bug broke it, then a developer can submit a query for review, and another developer can approve it. So 2 years ago, I also spoke at ElixirConf here in Orlando, and I spoke about a Postgres proxy. And that is another piece of QueryDesk that allows users to use their own database client, say Postico or DataGrip. And you get all the same protections, but you can use your own database client. But since then, I've been really putting time into making the browser-based client really easy to use, because I think it's a lot more convenient when you're on the go and you need to fix an immediate issue. So to just kind of give a quick visual of what this is, and hopefully internet actually works. So this is what QueryDesk looks like. So you get your query editor, can run queries, as you can see, like name, PII, so it's redacted. And the data protection is really nice because it's actually rewriting your query for sensitive fields so that data never even leaves the database. You also have ways, like if I wanted to update users, I can then submit it for a review. And towards the end of the talk, I'm going to talk about a cool open source library I've done that's around that review process. So one of the things that has made this application so powerful and even be able to be built in LiveView is the really easy hooks that LiveView has built. They've built really great JS interoperability. And that is through hooks. So you can have LiveView control or trigger different actions through using JavaScript to interact with the browser. I also really like to use web components, and specifically I'll build web components with lit. And this allows you to extend, essentially create custom HTML elements that get processed in your page. And they work really seamlessly with LiveView. So to show an example of a web component, I have one. So if you're following along with the links, it's link number 2. And I implemented a format date web component just to give a really quick, high-level look at it. So this is what a web component looks like. It's some JavaScript, some HTML, and what it does is it takes a date attribute, it formats it into the user's time zone, and also into the format that you would like. This is one of the problems I think that web components are really great at solving, because getting the user time zone is information that's available on the browser and not on the server side. So yes, you could implement something like a hook where you send the time zone up to LiveView and then you can process everything. But I think it's just easier to send the raw data down and let the browser actually process it. So to use web components, as I said, it's really easy. So once you write that web component, you would just import it into your app.js file. And then in your HTML, you just use the custom element. So in this case, format-date, you pass in your assigns for your date attribute and then a format attribute. Oh, and then to kind of show what that format date looks like, so on these column fields, you can see the underlying value is in UTC, but it has converted it to the user's time zone and also gives you a relative date of saying how long ago it was, which with a database view I think is really nice, because sometimes you'll see a date and just trying to conceptually think about how long ago. When you're in an incident, it's really nice to just oh, that was yesterday or that was an hour ago. So as I was saying, hooks are really nice to be able to integrate with really any JavaScript library that's out there. So I've used hooks to be able to create charts with Chart.js. I know previously in previous conferences I've gone to the how to generate SVG charts with Elixir to try to keep it kind of a pure Elixir implementation, but the implementations are never perfect and you lose a lot of interactivity. And so hooks just let you do that. It's you can, I don't think people need to shy away from you can't use JavaScript. I think that's what really makes a powerful user experience when you're building a LiveView application. The other thing I use hooks for is to interact with my web components. And so going back to the query view, this whole bottom aspect is a data table, or I call it the data table, and it's a web component implementation. And I use hooks to transfer data to it and also to send events back up to the server. And I'll talk about that here in a little bit. But a couple of things that I've been able to implement with hooks. So this the draggable sidebar is a hook to be able to adjust that. There's, you can use hooks to format the SQL. So this right here is just a Phoenix hook that then hooks into a SQL formatter library. Also have this copy to clipboard little icon here. And that will copy it in a format that makes it really easy to paste into Google Sheets. Now, the one caveat here is a lot of times when you're using hooks, you'll do something like a Phoenix click first, go to a handle event in the LiveView, and then send an event down to have it handled by your hook. But in certain browser APIs, like the copy to clipboard or passkeys if you've implemented them, the browser specifically relies on direct user interaction to allow you to trigger them. So in those cases, you don't want the server round trip, or you break that detection by the browser that being in the same cycle, essentially. So in this case, what I do is actually when the data table gets mounted, it adds a click listener for that icon, and when it gets clicked, it then processes the event all in that same click event. And if you're following the links, there is a link for the data table hook that you can then see the implementation of copy to clipboard if you're interested. So the data table. This is one of the main places that I really ran into a challenge implementing in LiveView. It started off first entirely as a LiveView implementation. I would go query the data from the database and then render the HTML, deliver that to the browser. But I quickly ran into some issues. So when I started off, the default limit for queries was 100 rows. And trying to render 100 rows in HTML, that's not too bad. But what I noticed is when I would try on specific tables, you can edit the fields, so you can interact with these fields. But when you do that, it's then having to, prior to LiveView 1.1, had to re-render the entire list if anything inside of that list changed. So changing attributes of saying, hey, this field is now in edit mode, triggered the entire list to re-render. And so it made this interface really sluggish. So like anytime you do any action, it would just freeze. But now, with this implementation, everything's handled at the browser level, so there's no back and forth messages. So that was a big issue. It's like, and this is only at 100 rows. And so to show kind of why this was an issue is this is a single field definition. So for every, like, imagine you have 10 rows or 10 columns and 100 rows. This is now 1,000 blocks of this HTML. And if all of those are changing, they all had to go down to the browser. So to try and make this more responsive for my users, I made each field its own web component. And by doing this, I shifted I only had to ship the HTML once to the browser, and that was included in the app.js as a web component. And then the implementation only passed the actual value to be rendered. This helped at the 100-row limit, but still had an issue as I would go up to, say, querying 1,000 rows. So the next couple things I was trying is the thought, like it helped the implementation, but then we started also running into another issue. If you would run, say, now you wanted to get 10,000 rows, 100,000 rows to be able to query and like export to a CSV, then to render all of that HTML, LiveView has to keep all of that data in memory. And so I actually had a customer, like that's how I discovered this, is a customer tried to run one with 10,000 queries, but it was crashing their application. And what it was is it was using all the memory on the pod, and Kubernetes was killing it. So the next thing I tried was streams. So streams allow you to insert data into the HTML. You don't have to hold it in memory. So this helped at the 1,000-row mark. But then going to 10,000 rows, the problem I ran into is now your browser is trying to render 10,000 elements in the DOM. And your browser will start freezing when you're trying to render that much data. Typically with streams, you might implement something like infinite scrolling. LiveView has really good guides to implement that. But in order to do that, you either need to be able to hold all that data in memory so you can selectively render different pieces, or be able to go to a data store and get those pieces in chunks. But with the nature of QueryDesk, where users can type in arbitrary queries, there is no way to predictably add pagination to a query. So that ruled out streams. And that is where I ended up turning the entire web component, the entire data table into a web component. So the web component is quite complex. There's a whole code, so it's link number 5 if you are interested in that implementation. But this is essentially how I use it now. There is the data table web component, and I will add the Phoenix hook to it. I also give them all a unique ID because I have a generic hook that has a handle event, and it listens for LiveView events to send to specific ones. And there are pages, like I have dashboards, that will have multiple of these on a page. And if you send an event to a LiveView, it will be picked up by all of them. But by adding the element ID into the listener, it will only handle events destined for that specific instance of it. So for example, with exporting, you'll click the button, the export button on the query view. You'd click the export button. That's going to then send an event to LiveView. If I could scroll back. And that's going to send the, it's going to push event to the hook, and the hook will then create a custom event and forward it onto the web component, which then can trigger creating a CSV file and downloading it. So the reason the web component solved the issues here is because Lit has a really nice library called Lit Virtualizer. And so you can give it all of the data and all of the HTML you would want to render. Well, you essentially give it a template for like, here's how to render each row. But then it only renders the ones that are actually in view. And so you're not inserting all of your elements, all of your 100,000 rows into the DOM at once. It's only as it's in view. And this makes it extremely fast because you don't have to go back to the data, back to your server to get the next page. And so if you're scrolling really fast with streams on LiveView, if you don't have enough loaded, you can definitely get weird kind of like scrolling or like loading spots. But by handling this entirely on the browser, you can have instant scrolling through hundreds of thousands of records. So want to give a little bit more context on the whole run query lifecycle so you can see how all the different web components that I have on the page interact with the LiveView. So first starts out with a user typing your query into the query editor. So in this case, I used CodeMirror. So this is implemented as a component. And then it uses hooks. So once you click the Run Query button, that will send the handle event to LiveView. LiveView then pushes an event back to the CodeMirror to say, hey, give me what your query is. That gives you the cursor position and the full window of the query so that you can then determine what query the user is actually trying to run. So that sends the query back to LiveView, and LiveView will then start a task running repo.stream with that query. And it will take chunks off of that stream, and it formats them, and then I use Brotli compression and send those back to LiveView. And then LiveView will then forward them on to the data table component here at the bottom. The really nice thing about using a task here is with LiveView, you can put that task PID in your assigns. And so if the user wants to cancel the query, they are able to do that. So like if we ran, demonstrate this, I can't type on the ankle. So we have the sleeping, but we can just cancel, and that will then just kill the query and the process that was running it. So if you have a long-running query that is not working out, you are able to do that. One caveat is, so I mentioned I use Brotli compression, which I'll get into more details on the next slide, but Brotli compression then results in a binary, and LiveView only does JSON messages. So I do have to base64 encode that binary, which adds a little bit of overhead, but you still benefit significantly from the compression before sending it over the LiveView event. So I think that'd be something really cool if LiveView at some point supported just raw binary messages. So as I mentioned on the Brotli compression, I ran a benchmark here because I've been hearing a lot about it. Brotli has, I know Cloudflare, I think, switched to it as their default compression algorithm due to better performance characteristics. And so in this case, in smaller payloads, Brotli will have a higher compression ratio, but be slightly slower. But notice we're talking in microseconds here. But as we get to a really large payload, like almost a megabyte in size, then the compression ratio really is significantly different and also significantly faster. Now, this could definitely vary by payload size, and I specifically used quality of 5 for this benchmark. The full benchmark is in that gist if you're interested. But yeah, I'd recommend like running it on your payload, and then you can increase quality if you would rather have a much smaller payload, but you are going to be spending significantly more time compressing. So, and this became very important because, like, as you know, it's like some of the tables that you're querying are very large, especially when you start working with JSON columns. And so by compressing that down, you significantly reduce the waiting time that your user is waiting to get the data. So last piece I want to talk about is LiveSync. So as I said with the query review process, I created this library because prior to this, I was using PubSub, and I just needed to, like, if I wanted to do live updates on a page of like, hey, some backend system event happened, let me tell my LiveView to update. And then Jose gave his talk last year and had the idea to use postgres replication. I didn't go as ambitious as him, like trying to make the whole front end just entirely based off of it. But I built it to just be around LiveView. And so this will look at your LiveView assigns, and any ecto schema that you subscribe to and that you tell it to update in your LiveView, it will automatically update for you. So it will even work for, say, if you have a foreign key ID and that foreign key ID changes, it will mark the relationship as not loaded so that you have an indication that you need to reload that piece. So I want to give a quick demo so you can see what that looks like. So on this right side, I have a second user logged in. And on this left side, I have my primary user. So I'm going to submit a query for approval. And then on the right-hand side, we should see that pop up. And we can even leave a comment. And then we should see now the left-hand side should get that. And then we can also say, OK, now you're good. We can approve it. And then now on my side, I am able to run that query. So to kind of talk about that implementations, like as I said, you would put in what schemas you want to be able to watch. It has a subscription key, so you can support multi-tenancy. And so you only are submitting updates to the proper user. And then on your LiveView, you would use the LiveSync macro. And you're able to say, hey, watch these assigns. When this changes, I want you to update it. There's also a way to override the default sync behavior that will go and replace your assigns. And you can use it more as an event to then take actions. And that's exactly what I do on the pending queries page. And that's because when you have a lot of users interacting with queries during the middle of the business day, there's a ton of updates coming in. And you have to load all the comments. The approvals, they're not all in that same object. So when you change a table on replication, it sends just that schema. So if you need really nested relationships, that becomes more difficult. So I have pending queries implemented as a debounce. And so once it gets an event, it will wait for 3 seconds, batch all those updates, and then preload them, and then update the UI. The next steps for LiveSync is, as Jose's example, it just uses the string protocol to get the data from Postgres. But I would like to look into if it's possible to use Postgres decoding to use the binary format instead. Also, as a DevX improvement, right now the config is all based on startup time. It will check what needs to be monitored. I think there would be some way to make that if you change it in local dev, it just automatically could refresh what it's watching. And then the last thing, which is probably a little bit more ambitious, is bulk processing. Kind of similar in concept like how LiveView does the update menu with live components. But if you have a bunch of users connected to your WebSocket at the same time for a specific organization, for example, the pending queries page, everybody's going to have that same underlying list of data. And I think we could bulk process the updates so that if you're trying to preload that whole list, not every user connected has to preload it, but you could have one shared process that preloads and then distributes to all the connected users at the same time. And that is all I have. QueryDesk is available as an open source project, but it is also, I have a paid part of it as well. And if anybody tries out either LiveSync or QueryDesk, I would love to just hear your feedback and open for any questions.
There is a question online that says, does adding these web components into your app.js make your JS imports in the page render large, like one large app.js file? Or is there an automatic smart code splitting happening under the hood to keep your JS bundle size what you need for the specific page?
Yes, so I have done some basic analysis of my page. I have not gotten to any of the smart splitting yet. And let's actually go check what my current bundle size even is. Let's refresh. So looks like I'm at 424 kilobytes being transferred. So guess like it could be smaller, but it's still it's not problematic right now. And to use this tool, you usually need a pretty reliable internet connection to be able to do database queries and the amount of data. So it's not a place I have particularly needed to optimize for, but it's definitely something you should. And I know there's a tool I used, I forget what it's called, but I did run my bundle size through that and was able to find kind of dead JavaScript imports in chunks. And so sometimes there's easy ways to reduce the bundle size, so it's always good to check.
Yeah, I'm just curious, you talked a little bit about some of the performance problems you had when you first got started rendering rows in LiveView. And it wasn't clear to me, like, if you went down the path of making each row a live component. And if so, what the impact was of that. Because that seemed like the standard. Now I guess there's keyed values, but back up until recently, that was the go-to method. I'm curious your experiences there.
Yes, that would be my nervousness and like just forgetting like half my points. But I did actually intend to talk about that. So prior to moving to the, well, no, I think it was actually after moving to the data field component and not getting the benefits I wanted, I started looking into, well, why does it have to render the whole list over and over again? And so then I did end up making each individual row a live component. But then the downside there is you have extra memory usage on your server. But still ultimately got to the point, well, I have queries that, so like, I have some users who are like, hey, I need to query 10,000 rows. And that still breaks down even if you're using live components with that many elements in your DOM. So I think the now just upgrade to LiveView 1.1. But if you can't, yeah, live components are your way to not have to re-render the entire list.